Journey starts now. Ever stared at a number and felt like it was hiding a secret? Take Goldbach's conjecture, proposed way back in 1742. It says any even number bigger than 2 can be split into two prime numbers. Simple, right? Yet we've been trying to prove it for over 270 years. We've checked trillions of numbers and it holds. But why? Is it just cosmic luck? Or is there a deeper reason baked into the very fabric of numbers? So how do we crack this? Forget just crunching symbols. Let's talk about meaning. Think of the Dick framework: data, information, knowledge, wisdom, purpose. It's like building understanding layer by layer. Now imagine the universe starting as pure nothingness. Then, bam, a difference appears, something versus nothing, chaos. Our cognitive system freaks out, needs balance. It creates a new concept, a closed loop, to contain that difference. That's the birth of one. From there, each new number is another little semantic leap, another way our mind resolves tension and builds a more complete picture. Numbers aren't just dots on a page, they're ideas born from this fundamental process. Okay, let's zoom in on the players. Even numbers are inherently balanced, like a perfectly symmetrical bridge arch. They want to be split evenly. Odd numbers? They're always left with one lonely unit hanging out. Primes are the indivisible building blocks, the atoms of the number world. They can't be broken down further without losing their essence. Here's the kicker: an even number's very definition demands this pairing structure. It needs two fundamental unbreakable units to achieve its balance. If you try to build it with non-prime bricks, like 6 plus 4, eventually, those bricks break down into primes: 3 plus 3 plus 2 plus 2. The core truth remains: every even number fundamentally requires two primes to hold its structure together. Goldbach isn't just a pattern, it's the logical outcome of how these concepts are defined semantically. Now, why hasn't traditional math nailed this proof yet? Because formal proofs are great at following rules, but terrible at explaining why the game itself is set up that way. It's like using a microscope to figure out how the lens was made. Semantic math asks the why. It looks at the infinite nature of the conjecture. Formal methods get bogged down checking case by case. Semantics says, hold on, primes go on forever. Euclid proved that. So no matter how big an even number gets, there will always be enough prime candidates to pair it up. It's not about verifying every single instance. It's about understanding the underlying structure that guarantees the existence of these pairs. This makes Goldbach feel less like a wild guess and more like a fundamental truth woven into the semantics of numbers. This all connects through this idea called the DWP mesh. Think of it as a web where different levels of understanding constantly influence each other. And when our brain hits a snag, a semantic bug, that's when consciousness sparks. When we face a tricky number problem, that tension triggers a leap in understanding. It's how we move from just seeing numbers to truly grasping their relationships. So next time you see an equation, remember, it's not just symbols, it's a story, a reflection of how our minds construct meaning from the world around us. Pretty cool, huh?